In this lesson on Java algorithms, we will learn about another sorting algorithm, which is selection sort. So what is selection sort? Selection sort maintains two parts, and if you're using in an array, so it will create two parts in the same array. One is sorted and the other is unsorted. And from the unsorted part, it will pick up the correct value to be put next into the sorted part. And so at each step, the array will keep on getting sorted one more part, and at the end of the whole thing, it is completely sorted. So let's look at an example to understand it. Suppose we have this group of numbers in an array and we want to sort them. So our starting array is 10, 8, 15, 7, 9. And nothing is sorted so far, so our start position is 0. Now within this array we will look for the smallest value. Now which is the smallest value? It is 7. And what is the location of the smallest value? 0, 1, 2, 3. It is 3. And once we have found the smallest value, we will swap it with the start position. So if we swap the value which is at 0th start and smallest, which is 7, so how will the array look after the swap? So 7 will come here, 8, 15 are the same, we don't do anything with it. 10 comes in place of 7 and 9. So this is how we are at the end of the first pass. Now at the start of the second pass, the output at the end of the first pass is being used. And now our start position is 1. Why is it 1? Because now this part of the array is sorted. We wanted to sort it in ascending order. So now it's sorted till here. And this is the part that we need to sort right now. Now what is the smallest value here? It is 8. What is the index of the smallest value? It is 1. So now we will swap them. And in this case, this happen to be the same. So the swapping will again look like exactly how the array was initially. So once we swap them, this is how the array will look like. Now this becomes a starting array again. 7, 8, 15, 10, 9. What is our start position? Now 2. Why? Because this part of the array is now sorted. So in the remaining part, which is the unsorted part, let us again find the smallest, which is going to be 9. Now what is the position of 9? It is 0, 1, 2, 3, 4. So 9 would be at position 4. And now at the end of the pass, what do we need to do? We need to swap the values at position 2 and 4. So now when we swap it, so 2 at position 2 comes 9 and at position 4 goes 15. So now this becomes the starting for the next loop. 9, 10, 15. Now we will start from the position 3. What is the smallest value in the remaining unpart? It is 10. What is the location of this? It is 3. And now once we swap them, what do we get? 7, 8, 9, 10, 15. Now at the end of this loop, if we can look at it, what is our sorted part looking like? So our start position should have been 4 and this would be a sorted part. So now if only one value is left, that would obviously be sorted if this is sorted. So which is why this loop will run till len minus 1 times, the number of elements minus 1 times. So we run it for so many times. And now at the end of it, we have a sorted part. So this is how a selection sort is used. So notice we did not create any new array. Within the same array, we created a sorted and an unsorted component in our mind, and we used it to do selection sort. And at each time, a part of the array got sorted. So here, this was the sorted part at the end of the first part. This was the second. At the end of the second pass, this was sorted. Now at the end of the third pass, this was sorted. And now at the end of the fourth pass, this was sorted, and because only one value was left, so completely sorted. So this is selection sort. So let us just try and understand the algorithm for selection sort. So for I is equal to 0, I less than len minus 1. Why do we do len minus 1? Because we run it for n minus 1 times. We take the value at the ith position. So we're starting from 0 because the sorted point was starting from 0 and it's continuously. So I is getting represented here. So this is what I is getting represented in the algorithm. We take the initial values. So we are initializing min and the min position. And now from the for loop, from I to less than n. So from I to less than n means when it was 0, we were looking through the whole array. When it was 1, we were looking from here. So we're starting from this position because this part of the array is always sorted. And we find the minimum and we keep on updating. So at the end of the loop, we have the correct value of minimum and min pos. And what do we do after this loop is over? We just swap them like we did. So we just swap them. And at the end of the loop, at the end of this ith loop, when it gets over, the outer for loop, we have the whole array as sorted. So this is selection sort. A couple of things about selection sort. It's another simple sorting algorithm. It is inefficient as it is order n square. Why is it order n square? Because here we will be checking these values. So again, like we did it in the case of in the first loop, how many times does the first loop run? The first loop will run n minus 1 times. The second loop will run n minus 2 times. So on till 1. How do we know this? We know this because let's go back to the loop. How many times will this loop run first? If I was initially 0, it will run n minus 1 times and so on. So this is order n square. So this algorithm is order n square, and we know that efficient sorting algorithms are order n log n. So it's a very simple sorting algorithm, although not the most efficient one.